Pulse field ablation using a lattice electrode for focal energy delivery, biophysical characterization, lesion durability, and safety evaluation. Radiofrequency is the most common energy type used for ablation of atrial fibrillation, but it can occasionally result in thermal-induced injury to the esophagus and to the phrenic nerve. Pulse field ablation, or PFA, is a non-thermal energy selective to cardiac tissue and may provide safety advantages over RF ablation. PFA catheters have been developed for one-shot technologies designed for standalone PVI. However, these technologies do not allow flexible lesions often required for complex cases, such as mitral lines or roof lines. A novel technology was developed by AF using an expandable lattice tip electrode for point-by-point lesions of either RFA or PFA. The aim of the present study was to investigate the effects and safety of this novel technology on atrial tissue. The system includes a generator that can produce either RF or PF energy, and a bidirectional catheter with a shaft of 7.5 French. The catheter has a lattice tip electrode with both mapping and ablation capabilities. The lattice tip is made of a compressible 19-0 mesh that expands to a 9 mm sphere once in the body. The sphere has 9 microelectrodes distributed evenly on its surface that act as thermocouples during RF ablation. The catheter has also an irrigation system through central micropores. PFA energy is delivered with a biphasic wavefront in a microsecond range with current output around 24 amperes. With each application, multiple pulses are delivered during a time period of 2 to 5 seconds. The generator can also deliver RF energy in a temperature-controlled manner with 2 to 5 seconds per application with a limit of 75 degrees Celsius. As we can see in the graph, during RF ablation, temperature rise is sensed by the thermocouples, and this limits the current output, while in PFA we see minimal, if any, temperature rise. In both cases, EGMs are attenuated during the ablation and afterwards. The study included 21 swine in 2 steps. The first investigated the feasibility of PFA to create a posterior atrial line of block. The second examined the durability of these lines after at least 2 weeks of survival period. In both these steps, conduction block was evaluated using activation and voltage mapping, as well as spacing the line of ablation. Histopathology evaluation was also performed after sacrifice. PFA resulted in acute ablation line of block in all 14 animals, and durability after 35 days of survival was maintained in 6 of the 7 animals. All histological sections showed transmural lesions. The swine that had a chronic focal reconnection on mapping also had all histological sections with transmural lesions. This may suggest that the gap was less than 5 mm and got caught in between histological sections, or that this might not be a true reconnection, but an epicardial bridging. On the left of the figure, voltage and activation maps before and immediately after PF ablation are present. Voltage reduction, as well as activation block during pacing, are evident with early and late activation alongside the line. The next panel shows the effect of PFA on EGMs. The top panels show immediate attenuation of local EGMs, while loss of capture during pacing is seen below. On the right, durability after 35 days is shown with voltage reduction and activation block as we saw before. Cross pathology in 6 of the 7 animals demonstrated a continuous ablation line from the superior vena cava to the inferior vena cava. In a single animal, a 3 mm gap was seen between the SVC and the high right atrium. The ablation lines correlated with the voltage reduction lines on bipolar voltage maps. Histological analysis showed transmural lesions in all sections. An example of PFA-induced lesion showed transmural connective tissue replacement with the myocardium, with sharp borders between healthy tissue and fibrotic tissue. On higher magnification, we can see sparing of blood vessels and nerve endings. To conclude, the lattice catheter was able to create atrial line of block with PFA. This was achieved with a small number of application and ablation time due to the catheter's large footprint. The ability of a single catheter and generator to toggle between PFA and RFA may be advantageous. Studies on the safety and efficacy of this technology, as well as optimal dosing in humans, are under investigation. Thank you very much for listening.